In this first tutorial for our Learn It V8 series, we're going to focus on the piston assembly. For this tutorial, we will create or model all of the components that are needed to finish our piston assembly, including the piston, connecting rod cap, wrist pin, and then add the 12-point screws from the McMaster car library. Hope you enjoy this tutorial from the Learn It channel. So the first thing we're going to do is save our file, and we'll call this our piston assembly. In the past, we've created tutorials that both use separate files or separate projects that we insert into a master assembly, and then other tutorials we've created in process designs, or we've created the whole assembly in one file with all of the components in that file. That's the approach that we're going to take today. It's especially beneficial for those that have personal licenses that can only create 10 active projects or files at any given time. And this way you'll be able to create all the models or components within one file. So the first thing we're going to do is create all of our different components. And the way we can do that is just go to our top item of our assembly. You can see it's only one component right now, but as we add a new component, it will create an assembly for us. So this will be our piston. Now what I'd like to suggest is instead of activating it, I would like to take this off, and I'll show you the difference if we don't take that off. I'm going to press OK. Right now it's created our piston for us as a component, and you can see now the symbol has changed there for piston assembly to an actual assembly because we'll have several components within that assembly. However, it has activated our piston. So if we were to just go to repeat new component, look what happens as we, well, I'll just say connecting rod. It will place the connecting rod underneath the piston as a child component or a child to our piston now becomes an assembly. So clearly we don't want that. We want to activate our main assembly so that all our components are built underneath this piston assembly here. So let's do this one more time. We're going to create a new component. We'll do it through that method. We'll call this our connecting rod, and I'm going to uncheck the activate box. Now it will place our components all within our browser, but not with continuing to make a child component one after the next. So let's do another one, and you can see activate is unchecked by default now. We'll make our connecting rod cap, right click on our canvas, repeat new component, that's the easiest way. We'll call this our wrist pin. And for our last component, which is actually the 12-point screw, we're going to save that to the very end because I'd like to show you one aspect of whether or not we're going to create an assembly with 2 screws in it, or if we're just going to add 2 screws to our assembly as individual components. This will hopefully explain some things to you to help your assemblies to be organized, and will make it easier for you to make a drawing in the future. So let's just start with what we have. Now let's start with the most difficult component here, and we're going to activate our piston. So we have created a PDF document that lists all of the different components and all the different dimensions for this piston assembly. And this is made available to all of our patrons and our members on our YouTube channel. So as we look at our drawing, remember something fundamental about 3D modeling is, especially when we look at complex shapes, we get intimidated and we think, well, where do we even start? Well, we need to break down all of these shapes into their primitives and then go into the fine details from there. So let's do that with our piston. If we look at our drawing, we have a simple cylinder. So let's make that cylinder. I am going to create a sketch. I'm going to do it on the XY plane. And we're going to create our diameter here at 5 inches as specified in the drawing. And here I'm going to make my datum surface the top surface. So everything is going to be built down negative in the Z direction. So let's extrude that. And our distance here is 3.2 inches. And we're going to go negative 3.2. So this is the basic outline of our piston. Now we'd like to hollow out the inside. So for that, we're going to create a sketch on the bottom side. And we've got to find these dimensions. Again, I'd like to stress this with all of my students and all of those that are learning. If you have the drawings, check off each individual aspect of the drawing so that you know that you have actually modeled it. So for here, we're going to call it 4.5 inches and finish that sketch. And now we want to extrude it inwards so that we match up with the drawing dimension. So here we can do one of two things. We can do the math, which is minus 3.2 plus 0.75. Or another way of doing it, this is the math here according to what we see in the drawing, but another way of doing it is we can go to Object, and then we can offset it 0.75. Let's go minus 0.75. That's another way of doing it there. Either which way, whatever goes faster for you and makes more sense, will do the trick. Let's go OK. Now we've got our hollowed out piston. Which are looking really good. Now at this point, we can determine what are we going to do next. Well, we can do the two pins that extend from the inside of our piston here, or we can do the cutout. Now I would rather do the cutout first, because if we make the pins, we can't do a cutout all the way through without interrupting those pins. So we have to think, well, what is the process that we're trying to figure out? How will it affect other aspects of our model? So let's do the cutout here. And I am going to go to, well, let's go to our right profile. And we're going to create a sketch. I can just do that on the YZ plane. And here we can create, I'm just going to create a standard rectangle. Again, we're going to use constraints here. This is an exercise in understanding constraints even more. So why don't we just use them? Now, we can make the bottom line collinear with this only if we project it. So let's press P, select our bottom line, go OK. Now if we rotate our view cube, you can see we've got a projected line, and that's actually the curve, the arc of our piston. Once we have that projected line, now we can make the bottom of our rectangle collinear to that. And again, if we move our view cube here, we can see that no problem. Now we'd like to make this perfectly symmetrical. So right now you can see, and actually what we can do is hide our body just to make it a little bit easier for us to see our sketch. But we can see here, yeah, we've got both these lines. We need to make them symmetric with the center line. So let's just do that. We're going to create a line, call this a construction line by pressing X. And now we can make those two lines symmetrical with that. Now, how high does this need to be? Well, our dimension is 1.7. And the width is going to be 3 inches. So let's just do that there. Great, everything is black, which means everything is constrained. So let's finish our sketch. We'll turn on our body now, and we can simply extrude this. And we can go both directions here. We can go symmetrical. And instead of specifying a value, I like to go to all, and it will just cut through everything right there. Now it's looking more like a piston. Now I'd probably do the lugs or the pins on the inside. So let's make sure that this is oriented properly. And they're going to be in line with the cutouts there. So we're going to go to our bottom view, and I'm just going to rotate it right like that. And now we can design our lugs. So to create a sketch, we can create it right on this internal surface. Don't select any of our planes over here, but the internal surface. And remember, if we've got something that can be mirrored, well, mirror it. And I like to try and do it, if I remember, in quadrant 1. If you're wondering about quadrants, I'll put a link to one of our previous tutorials which explains about quadrants even more. But I like to do it in quadrant 1. If not, well, you can do it in any quadrant, but in this case, it's easy just to mirror it to another quadrant or 2. So let's just create our lug dimensions right here. And for this, we are going to have a center line as well. Let's just create that and call this a construction line. And then we're going to select our center line here, and then select our object, and then right click, and we're going to select diameter dimension. And this shows a symmetrical dimension from either side of that center line. So here the dimension is 1.25. We're going to do the same thing for the outer dimension there. So D, center line, outside, and then right click, diameter dimension, and we're going to call this 2.75. The height of our lugs here are going to be 2 inches. And now we have to make this symmetrical to the center there. So let's create another line. And we'll call this a construction line and make this symmetrical to that point. And that will lock it in. Remember, if we're ever having a hard time with constraints, trying to figure out, well, what constraint do we use? It's always good to grab the blue object, the blue line or curve or whatever it is, and move it. And you can see, okay, well, this is the issue. Everything else is locked in except for these two blue lines. And they're 2 inches apart. That's great. But obviously we need to position it in reference to that center line right there. So again, we're just going to go symmetry, click those two and our center line, and we're good to go. Let's finish that sketch. Now we can extrude this. And this is going to be 3.25 minus 0.75. And this is slightly taller than the piston, or extends slightly past the piston, I should say. And we're going to join that. And now we can simply mirror it to the other side. But what would be better than mirroring it and then having to do all of our different fillets and everything like that? We can actually fully finish that lug and then mirror it once it's complete. It just saves a lot of effort with creating 2 sets of fillets and all of our other features. So let's do that. Let's create our hole on the lug here. 1 inch diameter. We need to make sure that this is perfectly centered with the center line. So we're going to do vertical, horizontal constraint. There we go. And this is 2.2 inches from the end. Perfect. Finish our sketch. We can just extrude this right on through. And again, we're going to go to all. Now let's create our fillets. So we're going to go there. We're going to pick those 2 edges. And this is 1/2 inch. Now we've got an option here. I like to keep as few items in the timeline as possible. However, at this point with our fillet, we kind of run into an issue with expediency versus keeping our timeline nice and short. And I'll show you the difference here. We could add another selection set. In this case, our fillets revert to their original position until we add or select our additional edges. So now I could pick 1, 2, 3, and all of the edges that need to be selected, but sometimes that takes a really long time. So what I'll do here is I'll remove that selection set and I'll just go OK. And I'll show you here with a fillet now is it will pick a chain or anything that is completely tangent to each other. It will select that entire chain. So look at this. Now I just select 1, 2. Makes it a little bit easier. In this case, you might not see the huge difference, but again, you can ask yourself the question, should I create 2 fillets in the timeline and make it easier to select the second set because it will pick a chain? Or will I just use everything under 1 fillet command? Well, that's up to you. You have to make that executive decision when you are modeling. Now here we go. We're going to pick those 2, and we're going to pick those bottom edges as well. And this dimension is 0.1. So that will make everything look really nice right there. Perfect. Now we can mirror this to the other side. Let's go mirror. And instead of our object type, let's select features. And we can just pick, actually, we can pick that extrude, hold down Command or Control, pick those 3. And we're going to select our mirror plane as our plane right there, and everything should mirror on over. Oh, we've got an error right here, compute failed. So what I've selected is rather than, well, I'll show you. So we're going to pick features again, select those 3, and instead of adjust, I'm going to pick optimized. Let's try that. Let's select our mirror plane there, and let's see if this works. Nope, that still doesn't work. So let's go to features one more time here. Extrude, pick those 3, and we're going to do identical. Let's do that and see what happens. So obviously we've got an issue right here, and that's okay. This is easy to rectify. If you see that happening with mirroring, that's okay. Let's just go back in time here. We're going to get rid of those fillets. Obviously I'm going to have to put these in after the fact, but now let's mirror just this feature on its own. Select the mirror plane. There we go. And that should have no problem at all. Oh, I see. I didn't pick the internal hole there. Okay, no worries. So there we go. I have to pick that as well. Easy. Let's just go back to features. And now I'm going to select, sorry, we have to go back to our timeline here and mirror 1, 2, 3, 4. There we go. Let's pick our, and adjust should work out perfectly. There we go. Now let's put in our fillets for our main piston as well. So we're going to go there. And we've got two sizes of fillets here. We've got these internal ones. And these will all be at 1 inch. We can add a selection set here. And we can pick all 4 of those corners at 0.375. Okay. So the next thing to add are our grooves up at the top here. So there's, again, several different ways of doing this. But I'm going to create a sketch on our XY. I am going to, or on our XZ, I should say. And I'm just going to, well, let's make our body visible again. I'm going to project. And I can actually select the top line here. No problem. Let's go OK. And hide our body. There's the edge. Now we can create a line. Now I have a couple different options here too. I can create all of the different grooves one after the next, and then add all the dimensions. Or I can just create one groove. If I look at the drawing, they're exactly the same. They're just spaced a certain amount apart. Very easy to do the math. So I think for myself, it's going to be a whole lot easier just to sketch one groove and then pattern it down the piston. Now we just add our dimensions. 0.3, and actually we will make this a chain. So this is 100 thou deep. We need to make this in line with that. So let's do a vertical. Oh, we need to pick our corner. There we go. And the height of our groove is 0.15. There we have it. Let's go finish sketch. Now we can grab our revolve tool here, pick our axis is going to be our Z axis, and look at what we've got. We've got ourselves a ring. We can turn on our body and it will default to cutting it out. So let's just do like that. Now we can just pattern it, and this is going to be a rectangular pattern. We're going to pick features for our object type, and we can actually pick that revolve command right there. Our axis is going to be Z, and now we can copy them or pattern them down the piston. And for its distribution, we can pick extent if we'd like. That's pretty simple. Or we can just go to our spacing and do the math for the spacing, which is 1/4 inch. And there we have it. All of our grooves are finished. Now, before we put the font on the top here, I am going to go to fillet, and we're going to add all of the tiny little fillets over here. So let's do these ones. And remember, it's a whole chain, so that makes it very easy to just pick 2, and it will select 32 edges automatically for us. These are fine edges just to add a little bit of breaking that edge. So it's going to be 30 thou for that. We're going to add another selection set, and all of these corners and edges will get a fillet on them too. So let's pick them. And these will just have a very fine broken edge of 2 thou. At this point, we can add our text to the top. So I am going to create a sketch on this face. Remember, don't pick the plane. We're going to pick the face. Why do we pick a face rather than the plane? Well, the face will actually inherit all of the dimensions or all of the features that are on that face. So let's just pick that. Now we can go create text. Here we can constrain it so that it's perfectly centered. We're not going to assume, we're just going to make it perfect. There we go. So we can type in learn it. And this is going to be specified at 0.5 as shown on our drawing, and it is impact as the font. There we have it. We're going to make it centered and in the middle for our alignment. We're going to make it bold. Go OK. And remember, at this point, we can move our text window and then constrain it. So I'm going to just make a couple construction lines going from one side to the next there. I could have actually just made one and then done a center point, but if we do two, it just shows what I'm doing. And here we're going to do a coincident constraint from the center to the center, and that makes sure that it is perfectly centered. Let's finish it. And now we're going to extrude our text. And according to the drawing, it is 15 thou deep. So let's do that, 15 thou. Cut it out, and our piston is done. So let's make sure we save that. Now we're going to move on to the connecting rod. So at this point, we can hide the piston and we can start working on the connecting rod. Now we could put the orientation of the connecting rod exactly in line with our piston, so it's a little bit easier, or we can model it with any orientation and then joint it later, whatever is good for you. It is best practice to design our model or our assembly so that everything is in place, but we don't have to do it that way. And that's the brilliant thing about Fusion, is we can join things later at any point and make the design process easier for us by creating our models on any plane in any orientation we like. And I'll show you how to do that here. So let's create our connecting rod. Again, we've activated our component. We've hidden our piston. So we're going to create a sketch. And what we can do is, it looks like on our drawing that the bottom of our connecting rod is our datum surface. So I'm going to start from there at our origin. So here we're going to create a 2-inch diameter circle. And then I'll create another one up at the top. This is going to be a 1-inch diameter. Now let's create a dimension in between the two of them. And again, we don't have to pick the center point. We can pick any point on our circle. And this is 6 inches apart. We'll create another circle out here at 2 inches. And we can move our dimensions off to the side so that we can see them a little bit better. Next, I'll create another dimension down here, another circle at 3 inches. And then I'll start adding the lines. So here we go. We're just going to go one to the next. I'm going to create a reference line there and call this a construction line. Create another line from this point to the next, and we can just go like that. Turn it into a construction line. And to make sure that this doesn't move on us, because right now it is not constrained. Or did it constrain itself? No. See, this is a point where if you don't know if it's constrained, then you build it off center and then make sure to constrain it, or else sometimes you run into big problems. So we're going to go coincident from there to there. Now it's black. And actually this isn't going to be a construction line because we want to extrude only this section. If we weren't to call it a construction line, well, then it would extrude this entire ring, which is not what we want. So let's turn that back into a solid line. Great. So if I look at our drawing right here, everything looks like all the primitive shapes at least are finished. And now we can move on to the next step. So let's go finish. Now we start having fun with extruding. So I'm going to just grab those two to start. We're going to go to symmetric dimension, whole length. So we don't have to do any math here. And this is going to be 0.95. There we have it. Our sketch disappears. Remember again to pull up our sketch. We're going to expand our component in the browser, expand sketches, and there we have it. Our sketches return. We can just make it visible. Now we're going to extrude this profile. We're going to go to symmetric, distance, and this is 1.25. And we're going to make sure the operation is joining. Very good. So there we have the primitive shapes, and now we just have to make it look beautiful. So let's hide our sketch. Now before we do that, we actually have our bolt positions over here, which are going to be threaded. And we can add that right now. So let's create a sketch on the end surface there. I'm going to project this surface in. Why? Well, we've created a sketch on this surface, but it doesn't pick everything on an imaginary plane and inherit those dimensions. We actually have to project the other side in order to utilize those as well. Well, actually, now that I think of it, we could just create our profile on this side and then mirror it to the other side. So why don't we just do that? That's easier. I'm going to undo that projection, and we can simply create our hole, and I believe it is right in line with, well, the spacing is 3 inches, so I'm going to do that instead. Let's just create our hole, and because we're going to use a hole command here, we can call this diameter whatever we would like, but the outside diameter is actually 0.375 times 2. So let's just do that instead. 375 times 2. Perfect, is 0.75. And now we can create a dimension, and we can select there to the center. And again, pick, oh, we can't pick a diameter dimension without creating a center line. So let's do that. It can be any length at all. Now we can press D, select that, select this, right click, diameter dimension, and this is going to be a 3-inch spacing, which is right in line with that. So that's perfect. And before we finish our sketch, this is actually going to be extended to the inner wall there too. So let's just do that. Now we can extrude all of this. Bring it on up. And instead of cutting, we're going to go to join. And this is 1 inch high. There we have it. So let's save our tapped holes to the very end. At this point, we can create a sketch right on that surface, and we can design it exactly as shown on our drawing. So I'm going to do a center point rectangle here. Let's just go up like that. Now we can put in all of our dimensions. So from there to there is going to be 0.9. And obviously this is going to be centered, so we're going to do a vertical constraint from there to there. So this surface is actually in tangent with the outer profile of our connecting rod. So how do we do that? Well, we can just create another circle based off of our center line there. We can just connect it to that outer line and it will create our circular profile. And we don't really care how big our rectangle is right now. We could put a dimension on it if we want. Well, why don't we do that? We can just go to our tangent and make those two tangent, and we could make those two tangent if we wanted. But the point is here is we want to extrude what's on the inside. So let's go finish sketch, and we're going to extrude this now. And this we can select to object for our distance and select our X, Y plane, and then offset it to our value on our drawing, which is 0.45 divided by 2. Oh, and we want to go plus. There we have it. Okay, so now we can create all of our fillets. Well, before that, why don't we just mirror this other side here? So we can mirror our features and just select that. Mirror plane. Well, before we do that, we can actually put our tapped hole in. So we can create a sketch right there. And then we should be able to create a center point for our circle right there. And you can see a concentric constraint shows up. We could just delete that as well. We could create another circle of any size and then use our concentric constraint in order to make it concentric with that circle right there. It really doesn't matter the size of the hole, because at this point we're going to create our tapped hole, and we'll select that point. And what do we want here? Well, it's actually a 120, a 1/2 20 UNF 2B, perfect, and it's going to go all the way through. So let's go all. Remember, we can select the size, the designation, and the class, and we can even create a direction. We can make it modeled if we want, but we mainly use this for rendering, or we'll use it for 3D printing. So let's go OK. Now we can, let's mirror it. And we'll pick that feature, and our tapped hole mirror plane will be right there. Great. Okay, so now that we've got all of our primitive shapes done, we can make it look pretty by adding all of our fillets to it. So let's do that. Oh, we forgot to mirror this to the other side. So we can do that before we add our fillets. So let's select that, mirror plane, adjust. Okay. Oh, it went all the way through. That's funny. So let's do this. Okay, mirror. Just that section. Why is it going all the way through? Well, I don't really know why it's going all the way through, but that's fine. So we can, to show you another shortcut or thing that we can do, we can turn on our previous sketch right there, and we can extrude it. We can start from object. Why don't we start from there? And we're going to go distance. Great, our offset is going to be 0.5 divided by 2. And extension type is going to be to our object. And there we go too. It's just another way of extruding that profile. Okay, so now we can add our fillets. And I'm going to pick that inside face and this inside face to add all of our fillets at one time. It's going to be 0.18. And then the corners as well are going to be 0.18 of an inch. There we go. Flip it around, do the exact same thing. Hold down Control or Command in order to pick additional edges. And there we have it. And then lastly, I'll do another selection of fillets and I'll select all of the chains. So let's do that. Again, it's easier this way. And this is going to be just a 25 thou. Breaking the edge, it looks nice and sharp there. Very good. And I forgot to do this edge. That's fine. We'll get that in the future. And I may as well create some nice broken edges over here too. Let's see if that works out, and it does. Perfect. We can rotate and select our other edges there too. And why don't we select these edges just to make it look pretty. Again, we might not manufacture it this way, but we're having fun and designing something. There we go. Okay. Now remember, I forgot to add the fillet on this side, so we just have to find that in our timeline and again hold down Command or Control and we can select that other edge. So I think at this point our connecting rod is done. Let's save it. Now let's go over to our connecting rod cap, and again we're going to hide our connecting rod. First thing we'll do is create a sketch on our XY plane. We're going to almost do the exact same thing that we have just done with our connecting rod, but do the connecting component. So here is going to be 2 inches for the inner circle, 3 inches for the outer circle. Just going to move those over again. This is just for visual reference to move our dimensions like that. Now we are going to create, well, we're just going to start with that actually. And we can extrude it. We're going to go to symmetric, measurement whole length, and our distance is going to be 0.95. Okay. Oh, and before we do that, I should say, is we only want half of this. So again, we're going to create a line going from one edge to the next. We're going to make a coincident constraint to connect those two together. And instead of extruding the entire profile, we're only going to extrude half of the profile. And there we have it. So now we will create another sketch right there. We'll create a circle which is placed on the edge right there. And this is going to be the outer profile for our counterbore holes. So let's do that. We're going to call this 0.375 times 2. Oh, times 2. Okay, and then we'll add our lines off to the side here so we can extrude that entire profile. Let's finish our sketch. We can now extrude this 1, 2, 3. Bring that on down. And this is going to be a join operation. And this is going to be 0.6. Perfect. All right. So at this point, we are actually not going to create a threaded hole, but we are going to create a counterbore hole. So we can do that by just creating another sketch right there and selecting our center point. Again, it finds our center point if we just hover our mouse over approximately that location. And we're going to bring this up to 0.375 times 2 as well. Perfect. Let's finish our sketch. And we can extrude that profile up. All right, let's go OK. So now, as you can see, there's actually these little walls right here, which let's see what happens if we delete them. There we go. So this might actually make it extraordinarily hard to manufacture, but it looks a lot better. So why don't we do that? And instead of just selecting one face to delete, I'm going to delete that, and I'm going to pick both faces to delete, and it will keep it as only having one item in our timeline. So let's pick both those faces, delete on our keyboard, and there we have it. Now we can create our through hole, which is 0.531. Finish our sketch there, and we can extrude that all the way through. Let's go to all. Now, instead of creating the fillets at this point and then mirroring everything, sometimes I find that if you mirror complicated shapes, including fillets, sometimes there are errors. So what I like to do in this instance is mirror, and we can pick all of those items. There we go. And our timeline is a little bit easier. We can pick all three of those and our mirror plane. Perfect. Let's go adjust. Alrighty. Oh, and we forgot to mirror our deleted surfaces as well. So let's mirror them and go OK. Perfect. Now we can fillet everything to make it look a little bit pretty. So let's pick that. Pick all of our edges that we need. On the drawing, it specifies that these edges remain sharp. So we're going to do that. And if you ever see that on a drawing, that edges remain sharp, we just don't add a fillet to it. So here we break the edges, and is there a specification on our drawing? Yes, it's 30 thou. And if we go 30 thou, well, everything gets filleted at 30 thou. Great. Okay, done. Let's save that. Now let's go to our wrist pin, our easiest component of our assembly here. So we'll activate wrist pin. We will create it on our YZ plane, and our outer circle is going to be 1 inch, and our inner diameter is going to be 3/4 of an inch. Let's finish our sketch there. We'll extrude it. This is going to be symmetrical, hole length, and 2.75. And then we add nice big fillets, and we're going to have 1, 2, 3, 4, but instead of selecting 4 edges, we can just pick the face, and then specify our radius. Oh, and it doesn't work out there. Oh, okay, it's actually 0.05. There we go. All right, let's go OK. Wrist pin is done. Now we're going to move on to our bolts here, or our 12-point screws. So we can activate our master assembly. We can hide all of our components, and we can go to McMaster Cart. And this item is going to be 91271A 760 according to our drawing. So it's listed on the drawing. It shows it there. We can pick this one, no problem. And actually, there is one issue with the drawing. We could do a fully threaded screw, but what would be even stronger is a partially threaded screw. So why don't we find the screw ourselves? Now we're just going to pick screws and bolts. We can select our thread size, which is 1/2 20. Our length is going to be 1.5 inches. If we scroll down, we can select 12 point for our fastener head. And actually, we do not have a partially threaded screw, so we can just pick our fully threaded, which is in fact the very same part number that we picked before. So that's the reason why I went with a fully threaded screw, is they do not have a partially threaded screw. So let's download a step file. Remember, if we pick SolidWorks, which is the default download file, and we try and download it, it will say, no, this is unsupported. So please try the SAT or step format file. So let's go to step, download, and we're going to go OK. Now, we did have an option here. We could have created a new component. We could have called that our screws and then inserted 2 screws into that assembly. But there's a limitation in this, and this is what shows up in our drawing file. When we create a parts list on our drawing, if we've created an assembly, it will simply say that we have 1 screw, even though we have 2. But if we right click and go copy and paste this, it will automatically select it as 1 part item on our drawing, but show that we have a quantity of 2. So this is the way that I like to do it a little bit more. However, if you have hundreds of screws or hundreds of rivets or something like that, it might be good to create an additional assembly and then put all of your fasteners into that one assembly as another option. So now we've got everything in our browser. Let's save it and we can get to assembling our piston assembly. So let's just take it 2 components at a time. Let's start with our top 2. Now we're going to have to make one of our components stationary. And the way we do that is we can right click and we can ground it. Well, I would actually like to take our connecting rod and ground that eventually. So let's just move it off to the side here. And actually, we don't want our connecting rod right now. We can, well, let's hide our piston, our wrist pin right there. Okay, let's connect these 2 together. So let's join it and we can pick the center of our cylinder here, or our bored hole. And again, we can just hover over our face, hold down Control or Command. We can pick the center point and we can do the same thing for our pin. There we have it. Now, let's rotate this 90 degrees. Perfect. And let's put on some motion, because this needs to have some motion to it. So we're going to say that this is going to be revolute. Great. Let's do 180 degrees or 360 degrees of the ability to revolve. Okay, and now let's go to our connecting rod and we can ground it. So that won't move. However, our pin will move. We've just moved it here manually. Let's go to revert position to set it back at its normal position there. Now let's turn on our piston. We can move our piston up to the top and we can join it. So how do we join the center of those 2 bored holes? Well, again, I've shown this in previous tutorials. We can select between 2 faces. We can pick that face. We can select that face, and then the snap point is going to be our center. So we can just select the circle actually, and it will default to the center point. There we go. And our snap point is going to be, oh, we've already picked our snap point. Now we pick component 2, and it's going to be the center of our ring right there. And here we can leave revolute on for our motion, but obviously it's going to have some limitations. We don't want it to spin all the way around. So we can, there we go, joint motion limits. It didn't show up for some reason before, but now it did when I went to position and back to motion. So we want a minimum and maximum. As soon as we select minimum, you can see it in blue here. So we can grab our blue line and we just want to make sure that nothing's going to collide. Great, we can add a little bit more. And right now, that's about it. Let's go to 45 degrees. And we can add a maximum angle as well, 45 degrees to either side. And we can go preview limits. Okay, perfect. Now we're going to add our connecting rod cap. We can just make it visible and grab it and pull it off to the side. So let's go to joint. And we can actually just pick one of our holes here and we can pick its corresponding surface right there. And obviously we don't want revolute right here. We want rigid. And its position, we're going to angle it. And we're going to go to 0 degrees. Now, last but not least, we want to add our screws. So we're going to activate both of them, or make them visible, I should say. We'll pull it on down there, and we're going to join this surface, the center point, and we're going to do the exact same thing here. We're going to pick that surface and our center point, and it should orient everything nice and good and good and nice. There we go. We're going to do the same thing with our other, and we can join it. And go OK. Perfect. So our piston assembly is done. So just before we finish this up, let's put some appearances on it to make it look even better. So I'm going to go A. And although we're not using stainless in the actual manufacturing here, we just like the appearance of a polished stainless steel. And we're going to drag that into the main material in the design. It says there's an error. That's fine. We can just click on that again. Old material could not be removed from the document, possibly because it is the default material. So we've just changed the default material. That's fine. Now what we can also do is go, I kind of like the look of titanium screws. So let's go there, and we're going to drag and drop our titanium over the screws, and it will automatically make both of them the titanium look. And then I'll probably just add a black appearance to the lettering, to the font. So I find with appearance here in Fusion, if I were to go to faces and then change those faces, it would actually change the whole body. There's some sort of bug there. So I'm just going to go close. Let's save it. Now I'm going to go back to appearance, and the first thing I'm going to pick is faces, and we're going to go to black. And let's go black oxide. That looks pretty cool. And I'm just going to go to the right face here, select every one of the faces for the text, or the font, and I'm going to drag and drop. And would you look at that? Everything is looking great. You can refine it by going to joints and by changing some of these. So what I'd like to do is I like to rename the joints so that it actually tells us what I've joined together. So if we're unsure, we can always double click on that joint or edit joint, and we're connecting or joining the connecting rod to the wrist pin. So I'm going to call this connecting rod to wrist pin, and I'll just rename them and fast forward so you don't have to watch me do the whole thing. And then at the very end, if you don't want to see those joints, we can just turn them all off, and we have our finished product ready to be rendered. If you've benefited from our tutorial at all today, please consider liking and subscribing and smashing that notification bell. If you love our channel, please consider being a member. If you have any suggestions, put them in the comments below. If you've appreciated anything, put them in the comments below. Until next time, hope that you continue enjoying the process of learning Fusion 360 and continuing to learn with the Learn It channel.